So, today's class, we are going to study both laws of chemical combination. So, I already taught you what is first law of chemical combination. And today we are going to see what is the activities given in our textbook to study that first law of chemical combination. What is the first law of chemical combination, everyone? Yes, please. What is the first law
Law
of chemical
of
combination?
conservation
Yes. Law of conservation of, all of you? Law of conservation of mass. So according to the law of conservation of mass, so what is happening actually?
Reactant is equals to the mass of
So you
product.
take any kind of chemical reaction. So before reaction, if you take the substances who will involve in the reaction, we used to call it as a what? Everybody? Reactants. The substance which will obtain after the reaction, which we used to call it as everybody. Yes,
products.
products. So reactants may be involved one or two or more than one. Products also may come either one or two or more than two. So if I measure this mass of these reactants and if I measure this mass of these products, so definitely I'll put like mass of reactants and mass of products. So always remains equal. So that is only ways to say first law of chemical combination, which has a law of conservation of mass. Am I right, everybody? All of you, can you hear me? Law of conservation of mass. So now, if you take this one, these products and as well as reactants, these products and reactants, they may be solids, they may be liquids, or they may be gases. So you have to consider the mass of any type of substance. That is what you have to remember. Okay? Abhiram, balancing is different. This is different. You just wait. I will say you. Of course, unless you balance it, it won't be. But you listen first. Okay. Yeah. Balancing also I'll teach you. Already studied. I'll teach you. So as I said, this is what is like finally we can say total mass of reactants is equals to total mass of products. Yesterday I have given you the one example also, that is what carbon dioxide plus oxygen is going to give you carbon dioxide. So if I take 12 grams of carbon reacting with a 32 grams of oxygen, so we will get totally how much, guys? Everybody? 44 grams of carbon dioxide. So if I add the total mass of reactants, which is equals to 44 grams, products also 44 grams. So means it is mass remains conserved. Am I right, everybody? Means constant. That is what. So mass remains conserved. Will you all agree with me? Please respond. Clear, everybody? Yes? So from this we'll say what is law of conservation of mass? Everybody. Mass can neither be created nor destroyed, but there is a change in the energy reaction. Am I right or wrong? Energy may be generated or energy may be absorbed. So based upon that, equations or chemical reactions are classified into two types. What is that, guys? Everybody. Yesterday also I taught you. So chemical reactions based upon energy change.
Exothermic, endothermic.
Two types. That is what? Exothermic, and another one is endothermic. See, you have to show in exam also. Unless you get a good mark, nobody will believe your study. So only remember that and work. So exothermic means, keep it in mind, everybody, the chemical reaction in which energy is liberated. What do you mean by liberated? Everybody? Means generated or released, produced. These all are same meaning. So energy is liberated, or we can say released. Okay, when released, when reactants react to form products. Reactants react to form products. So that is what we used to call it as a exothermic reaction. Class 10th, every chapter will be having importance of this. Next, endothermic reaction means opposite to this. Here, energy is liberated or released. Here, energy is absorbed. Do you understand? When? Absorbed. When, guys? When reactants react to form products. Do you all understand what I'm saying? To form products is known as endothermic. Are you clear, guys? Please respond. Everybody. So this is what is exothermic and what is endothermic. Okay. So now we are going to continue to verify the law of conservation of mass. So there is an activity they have given in their book also. So let us verify that. Okay. So you can keep adding in your classworks. This, see, I'm going to make the concepts into like a 10th class level now onwards, so that you will get interest in equations, you will get interest in subject. So that is what I am saying. So this is the activity to prove that law of conservation of mass. So they are asking, is there is a change in mass when a chemical reaction takes place? Is it a change in mass? No. Am I right or wrong? Yes, please respond. All of you. That is what. So for that proving purpose, we have to take, you can see, take one of the following sets, X and Y chemicals. So in our laboratory, of course, if time permits, when you go to laboratory, if you studied with the one, you can study with another thing. So you can take a setup. So you can see copper sulfate. Formula is CuSO4. All of you read and say once with the mouth, then only it is easy to learn. Copper sulfate, CuSO4. Remember, from now at this moment, see the chemistry in the form of formulae, in the form of mass, molecular mass, and valencies and all. Of course, in this chapter, whatever you are going to study, everything will be like from now to entire your education. If you are in a like, if you go to NEET or whatever it is, it will be keep on following us. So that's much important. So next, the sodium carbonate formula is Na2CO3. So you can take a pair of chemical. One is copper sulfate and sodium carbonate, and you undergo the reaction. Next, barium chloride and sodium sulfate. Barium chloride is BaCl2. Sodium sulfate is Na2SO4. Lead nitrate. Lead nitrate is Pb. If you open your mouth, it will be nice. PbNO3 twice. How to read it? Everyone, we will study in this chapter.
twice.
We will study how to write a formula. You no need to worry. But I am saying you now itself we are getting. So let us have a glance. That's all, please. PbNO3 twice. Okay, pronounce once or twice so that you will remember. PbNO3 twice. Sodium chloride. NaCl. Purima, that's all. Now you can see. Prepare separately a 5% solution of any one pair of substances listed under X and Y, each in 10 ml in water. 10 ml in water. In that, how much percentage? Pakran. What is the percentage? Solution. 5% solution in 10 ml of water. We have studied in second chapter calculating percentage. Do you remember, everybody? Yes, all of you?
Yes.
Please respond.
Yes,
That is,
sir.
now you can see 5% in 10 ml of water means it is a what? Mass by volume percentage. Am I right or wrong? Speak, guys. Mass by volume percentage. Understand, Ara? Mari, Sanjay, Lingesh?
Yes, sir.
Yes. So mass, because keep it in mind, note it, I'm saying you, this all the substances, basically they are in solid substance. They are present in solid state. So if you dissolve in water, clear? Dissolve in water, they will call it as a aqueous state. What is to call? Everybody?
Aqueous.
Aqueous state. Remember, these all the substances, again you will get it in 10th class. These all the substances will shows the chemical reaction only when the reactants are in aqueous state. Purema, do you understand, everybody? When they dissolve in water and they will turn up into aqueous state, then only chemical reaction will take place. Is it okay, everybody? Clear? Yes, please respond.
Yes.
So you have to prepare a 5% of solution, that is what mass by volume percentage, in a different separate containers. Now take a little amount of solution of Y in a conical flask and some solution of X in an ignition tube. So what is ignition tube? Means test tube. This is what we used to call it as a test tube. Okay. And this is what we used to call it as a, what flask we used to say, everybody? Conical flask, Purima. And we have to completely seal it with a cork. Why? Anybody tell? Because gases should not escape. Because we have to consider gases mass also. Am I right, everybody? Please respond.
Yes, sir.
That is what. Clear? Everyone? Now, so small ignition tube, we have to take it as a what? X solution of X. And in a conical flask, we have to take it as a what? Solution of, please respond. Solution of?
Y.
Solution of Y. Okay. And you have to place it on a, Danishka, I will say you Danishka. You have to place it. What you have to do it means, all of you remember, you have to place this one in a measuring the electric balance. So place this conical flask in electric balance and measure the weight. So let me take for example, before reaction, have you seen now X and Y, is it they reacted? Is they reacted? No. Am I right or wrong? Still they are individual. X is inside the ignition tube. Y is inside the conical flask. Is they reacted? Please, I am asking you guys.
No,
No.
sir.
Okay. Now I measure the mass with including the weight of a flask, weight of a test tube, because they are liquids. We cannot measure separately. Okay. If you want it, you can do it that also. How it I will say. Okay. So what you have to do now? You have to measure the mass of this total. So totally we will get it. For example, I have got 300.23 grams. Actually, this is the value will take experimentally. So now I will allow to tilt this because I fixed it with a rubber cork. Correct? Now there is no reaction. I just shake it and I just tilted so that this X will come and will mix with what? Y. Understanding? Or Y will go and mix with the X. So something reaction will take place. Now finally we will get a solution of, all of you observe, in the conical flask. So X will go and will react with the Y. So we will get X will become empty. Understanding? And entirely we will get a solution here. So in that solution, and you can notice it, down there is an insoluble solid substance. What will form, everybody? Insoluble, speak guys. Insoluble solid substance. Okay, that insoluble solid substance based upon the products. So let me see X and Y. What do you want it? Whatever you say, I will say either first one, second one, and third one. Which one you want it? Everybody, you tell me.
First one.
Okay, first one. That is 3 also I will teach you. So after the reaction also, if I measure it with the help of electric balance, again I am getting the mass 300.23 grams only. So that I will say mass before reaction and mass after reaction is remains constant. So it is law of conservation of mass.
So doubt, sir.
Yes, Mari.
In the first reaction process, you are measuring the tube separately and the liquid separately, sir.
Listen, actually we don't want to measure the mass of the tube separately. If you want it, you can measure, Mari. Nothing is wrong. Okay. So
No, sir, the content inside the tube.
listen. You take flask mass separately. You measure it individually. You measure the test tube mass individually. Then you pour the liquid, you pour the Y solution, you pour the X solution, and together mass you measure. So what will happen? For example, total I am getting 300.23 grams. Flask plus test tube mass, if I got, for example, 200 grams. Remove it from this, then you will get only mass of these solutions. Puriyama Mari?
Yes, sir, that's what I'm asking.
But we
In
are
the
not,
reactant,
we don't want that. We don't want that because we are not considering that. We are putting directly test tube inside this. We are not taking, I am not giving you how much Y I am taking or how much X I am taking. I am not specifying you. Do you understand, Mari?
yes,
Clear?
sir.
You take some amount of Y and some amount of X and you put it in the test tube X and flask Y. You just allow them to react. So you measure the mass before reaction, you will be getting some amount, including the mass of the flask and mass of the test tube. Do you understand what I'm saying, everybody?
Yes, sir.
Are you clear, everyone? Please respond, including that. Now, after the reaction, just allow this test tube to tilt. Allow the test tube to tilt. So for example, I'll make the flask like this. Then test tube, what will happen? All the liquid X will come out and it will be mixed with Y. So just again you put it normal, then you measure reaction will carried out. You will get some insoluble substance here along with some solution. Okay. So that is what after the reaction completed, you measure the after the reaction also mass. So including the mass of the flask and test tube, you will get the same equal. So means both the mass is remains constant. Am I right or wrong, everybody?
Yes, sir. Sir.
That is what you have to remember.
Sir.
No. Yes.
Sir, even if we measure the masses of the liquid separately and add it also,
That
it will
is
be same.
also okay, but mass of the liquids you cannot measure. You need always a container to store the liquid.
Yes, sir. With the container.
You can remove it. That's what container mass you can remove it. Nothing wrong. But
sir.
Here we are not specifying. Do you understand, Mari? We are not specifying. It is not our target. We have to prove that conservation of mass. That's all. It is our target. Clear?
Yes, sir.
Yes.
Yes, sir.
So now you take anything. First one, copper sulfate and sodium carbonate. Everybody. So you can take it. Copper sulfate. What is the said? Dissolved in water. So if it dissolved in water, what is the state? Everybody. Physical state is what state? Aqueous state. What is that? Please respond. AQUEOUS. Aqueous state, everyone. Okay. Dissolved in water. Reacting with the sodium carbonate. That is also dissolved in water. Reaction will carried out. We will get copper carbonate. This is what? Insoluble solid. Insoluble solid, which we used to call it as a copper carbonate plus aqueous solution we are getting. That is what? Sodium sulfate. So which is aqueous state. So this insoluble solid only, we used to call it as a, remember guys, precipitate. What we used to call, everybody? Precipitate. Okay. So CuCO3. What is the name, all of you? Please respond. Copper carbonate, sodium sulfate. Learn. Sodium sulfate. If you learn, it will be very nice. Are you clear, everybody? Yes?
Yes, sir.
Yes. So that is what. So this is the first reaction. You can go with anything. So this one is already balanced. You don't need to balance it. But if it is not balanced, like 8th class, how you study, you have to study. If not, again 10th class, again you have to learn how to balance the equation. Okay. So next, second two equations. I'll teach you the both equations, all the three equations. You just learn it, that's all. So learning is only process, which will make us always easy. Second one. So second compounds what? Barium chloride. Am I right, everybody? All of you? Yes. What is the barium chloride formula I said?
BaCl.
BaCl2, which is also in what state? Aqueous state, dissolved in water, reacting with the sodium carbonate, sodium sulfate. Sodium sulfate. Have you checked it? Sodium sulfate is the product of first reaction. Am I right, everyone? Yes or no? Check it, verify it.
Yes, sir.
Yes. If you want, that is also you can. So, which is in aqueous state, reacting with that, and you will get the product barium sulfate, which is actually solid state. That is what we used to call it as a precipitate. What we used to say? Insoluble solid after the reaction. Note it. Insoluble solid after reaction is known as precipitate. Plus we will get NaCl. NaCl is aqueous state, but it is not balanced equation. Here sodium is 2, but here sodium is only 1. So I will make it into 2. So if I make it 2, it is balanced. Any doubt? Anybody can ask. Clear, everybody? Anything doubt, you can ask. Okay, guys. All of you, please respond. Yes?
Yes, sir.
Next, third equation. What is the third equation, everyone? What is the third equation? Aqueous state means dissolved in water. Any substance dissolved in water. They are asking us to prepare a 5% solution in 10 ml of water. Am I right, everybody? So any substance dissolved in water, that is called it as a aqueous state. Are you clear?
Yes, sir.
Yes. Next. Next one. What is that? Next one. Next chemical.
Lead nitrate.
Yes. Lead nitrate plus sodium chloride. Now you got sodium chloride here. Use that is at the next one. So PbNO3 twice. Alfin, do you understand how to read this one? PbNO3 twice is called it as a lead nitrate. Lead
Yes, sir.
nitrate. Okay. So lead nitrate. What is the physical state? Everybody. Physical state is most important in 9, 10, 11, 12. 10, 11, 12. Physical state is very, very important. What is the physical state, everybody? Physical state, please. Either it is a solid or liquid or gas or dissolved in water. What is that call it as? Dissolved in water. We used to call it as. Please respond. Aqueous state. These are the possible physical state of a reactants and products. Please note it. Reacting with the sodium chloride, NaCl, aqueous state. How many moles? Sorry, moles not, I should not use, I not taught you. 2. So 2 NaCl, let me take it as a 2 NaCl gives us PbCl2, which is precipitate, lead chloride. What is the name of this one, everybody? Lead chloride. Okay, precipitate it is. It is the precipitate plus sodium nitrate, NaNO3, which is aqueous state. Clear? 2 NaNO3. So that is what? Sodium nitrate. So whatever you want it, you can take in exam. Sorry, in exam not. Yeah, in exam they'll ask you, give one example. Any example you can take. Lab also you can test with anything. Nothing wrong in that. No harmful chemicals in this. and all are very simple substances. You can notice the reactions very carefully. That's all is the only thing I'm saying. So if all these three reactions, after the reaction, one insoluble solid is forming, that is only known as, what is that called, everybody? What is that called? Precipitate. Please remember that. Clear, everyone? Hasini, Sudhakar, all of you. So chemistry means chemical formulas. That is the reason I'm stressing on chemical formulas. Chemical formulas theriyada. There is no use of studying chemistry. Again, I'm saying, till today, your seniors are facing problem. Many people don't know what is chemical formula, even a simple compounds. There is a students who don't know sodium chloride, NaCl2, NaCl formula also. They will write NaCl2. That is their mental state today's. Even they are going to write a board exam after a few months just. So that's why that difficulty should not happen for you. So give high priority to the chemical equations, chemical formulas. Always what you are learning, going to learn in this chapter is highly preferred for every chapter in class 10th. I will prove it and I will show you also when I am teaching it. Okay. So that is what. So this is what is conservation of mass with examples. Anybody having any doubt, you can ask me, or else note all the equations and we'll proceed further. Any doubt? Yes, please.
Sir, can you please show the first equation?
Yeah, I have written in book, correct, Mari? Okay, then let us write it. What's wrong in it? You want it, you can write it, Mari. So all of you write it. What is that first equation? Copper sulfate, which is aqueous state, reacting with sodium carbonate, which is also in aqueous state, which will give you a solid precipitate. Solid, yes, precipitate plus sodium sulfate, which is also in aqueous state. Purima, ellame, understand? All of
So
you.
why is in all the reactions they are giving a precipitate?
We are taking examples of it. That's all, Mari. Do you understand it? Because at the beginning, I have written A plus B is equals to C plus D. Do you understand what I'm saying?
Yes, sir.
So let me write an example for according to this one, so that I'm taking two reactants and two products. So nothing else. Clear?
Yes, sir.
And balancing these three equations is very simple. This first equation is already balanced. You can verify copper 1. Sulfur 1. Oxygens 4. Next, sodium 2. Next, carbon 1. Oxygen 3. Balancing, maybe it is not easy for you now, but definitely I'll make you easy. That is my guarantee for you. Okay. Next, these two equations, how to balance it. Here sodium pakranga. Here sodium 2 erga, chlorine also 2 erga, but here only 1. So that I have to multiply with the coefficient 2. See, remember, only we are having a permission to change the coefficient alone. We cannot change the formula. Do you understand, everybody, what I am saying? All of you? Formula, chemical formula, you cannot disturb. Only you can disturb is coefficient. So here 2 sodium atoms is there, but here only 1. So I multiply with the 2, so that sodium balance. Then if I try to balance sodium, chlorine also, this 2 is belongs to both, like mathematics. Suppose I'm having 2 of AB. So can I write this one as a 2A into 2B? Am I right or wrong? Everybody?
Yes.
Yes, the same phenomena we are applying here. Next, chlorine 2, chlorine also 2. Next, here also same. But this one you see that. I will teach you when I'm doing it. This 2 is belongs to nitrogen, 2 is belongs to oxygen also. Then 1 lead atom is there. Nitrogen, how many atoms are there? Pakranga, tell me. N1, 1 into 2. Nitrogen, how many? Nitrogen, how many? 2. Oxygen, 3 twos are 6. So 6 oxygens are there. So this is what is the number of atoms. So this side also you verify it. So like that, if it is there only, you can. Otherwise, it is not. Now, here sodium, observe how I will balance it. So here you can see, here chlorines are 2, but here chlorines are 1. So that is why this side I will multiply with the coefficient 2. Ellame understand, Amma? Everybody?
Yes, sir.
Yes, that's one. So like that, of course, by choosing any atom, you can balance it. Balancing equation, I'll teach you. But 9th class, no balancing equation. But 10th class, that is the most important concept in chapter number 1. So this is what is about conservation of mass. First law of chemical combination. ಯಾರಿಗೆ doubt ಇರಕ, if you have any doubt, please kindly ask me. And you should learn it with the examples. All the examples, you go through that and learn. That's why I'm not leaving any example. Okay, so you have to learn everything without, you should not make a choice. You have to choose a choice from your learning. That is what I'm saying. Definitely they will ask you. Let them ask. The 2 ways they will ask you. So for example, even madam itself given X and Y compounds names, and she will ask you to write the example of conservation of mass. Or else she put take give any one example. Then your choice. Either they specified also, you have to be ready for that. If they are not specified also, you have to be ready for that. That is what is expecting from you. So this is what is about law of conservation of mass. First law of chemical combination. Next, second law of chemical combination. All of you write it. Most important law, law of constant composition. Yesterday also I taught you this. If you check it everywhere, like carbon dioxide in Pudukkottai, carbon dioxide in Chennai, carbon dioxide in Andhra, everywhere carbon dioxide means what is the formula? Everybody. CO2. That is what. So that is only we used to say indirectly. So not indirectly, directly I'm saying you. That is only we used to call it as a law of constant composition, or we can say law of definite proportion. Law of, everybody? Law of definite proportion. Purema. So this law was given by Mr. Joseph Louis Proust. What is the name, everybody? Joseph Louis Proust, in the year of 1799. In the year of 1799. Who has been given this law, everybody? Joseph Louis Proust. Okay. So according to this law, what it will say means, write it, everybody. A pure chemical compound, a pure chemical compound will have definite composition. What is that and all we'll discuss. Don't worry. I'll make many examples also. Definite composition or definite proportion. Definite proportion of the elements independent of its source. Independent of its source. Now see, you can produce the carbon dioxide gas by anything, by burning fuel, by respiration, by other process or other XYZ process, anaerobic respiration. Okay, whatever the method you follow, wherever you get the carbon dioxide, atoms are always remains constant. Am I right? Shivani, Kavya, please respond. That is what we used to call it as a, okay, law of constant composition, or we can say definite proportion. So what does it mean? During the formation of compound, write it, all of you. Explanation. during the formation of compound, all of you remember, formation of a compound, okay, the elements combine. The elements combined, and one thing remember, irrespective, that is what I use a word, independent of its source. Ellame understood? Elements combine in fixed ratio by mass. In fixed ratio by mass. So this is only call it as law of constant composition or law of definite proportion. So for example, let me take example and finish. How many of you know water? Anybody? Pure water. What is the formula of water? All of you? Pure water.
H2O.
Yes. Pure water, H2O. Understand, Nivedan? Lingesh, are you there, Lingesh? So if you take here, the elements combined in this is fixed by mass. So if you notice it, so pure water will have a constant composition of hydrogen and oxygen. Whatever it is the source, either it is from river or it is from your house or it is from ocean or it is from some other XYZ places. Water has many resources, underground water, surface water, whatever the water you take, anywhere, keep it in mind, water will have always having a ratio of, keep it in mind, water will always have hydrogen is to oxygen ratio by mass. Ratio by mass is 1:8. I am not asking element ratio. What is the mass ratio? What is the mass ratio? Everybody, please respond. 1:8. Okay. For example, sir, what does it mean? You take Pudukkottai water, PDKT water, 1 liter or 1 kg. Let me take it. Okay, that is better. If you take Chennai Central 1 kg. So now, if I take it, all of you observe. In that, if I cut it into 9 parts, if I make this mass into 9 parts, that is what 1:8. So this 1 kg mass, big 8% of it, 8/9% of 1 kg is because of oxygen. Do you understand, everybody? 8/9 into 1 kg of mass is what mass? Everybody. Mass of? Please respond. Mass of oxygen. Sir, how it will comes? I will teach you. Do you understand, everyone? How it will comes, I will teach you. Don't worry it. Understand, everyone? So how much it is? Next, what is the mass of hydrogen? Mass of hydrogen 1/9 into 1 kg means just one part of water is hydrogen and remaining 8 parts of water is oxygen mass. If you go to Chennai water also same. If you go to America also same. If you go to anywhere in the world, if I take 100 liters of water, in that, remember, 8/9% of water is mass, is what, everybody? It is mass of oxygen, and 1/9%